Hello, my name is Aunia Afika binti Karim, and I'll be presenting on first law of thermodynamics.
Hello, my name is Anish Thiru, and I'll be presenting on second law of thermodynamics.
First law of thermodynamics, or also known as law of conservation, is stated that energy is always conserved. This is because energy cannot be created or destroyed. Next, energy can be transformed. Energy can change its form to another type of energy. Lastly, as we know, the formula equation of first law of thermodynamics is delta U equal to Q minus with W. This means change in internal energy is equal to the net heat transferred to the system minus with net work done by the system.
Second law states that total entropy of an isolated system can never decrease over time and is constant if and only if all processes are reversible. I'd like to introduce these 5 gentlemen here. First one will be Lord Kelvin, second one will be Nicholas Carnot, third one will be Constantine Caratidori, fourth one will be Rudolf Clausius, and fifth one will be Max Planck.
As you can see, Nicholas Carnot, a scientist, created his own cycle called Carnot cycle. Based on the graph from A to B, it's isothermal expansion, while B to C, it's adiabatic expansion. Hence, C to D will be isothermal compression, while D to A is adiabatic compression. The Clausius inequality for a closed system states that the process is irreversible if delta S is more than delta Q, and the process is reversible if delta S equals to delta Q. Kelvin's statement says that it is impossible for a self-acting machine, unaided by an external agency, to convey heat from one body to another at a high temperature. Kelvin and Planck came to a conclusion, so they created a statement called Kelvin-Planck statement. However, Planck also had his own statement, which is every process occurring in nature proceeds in the sense in which the sum of the entropies of all bodies taking part in the process is increased.
The principle of Caratidori describes the concept of adiabatic accessibility and providing the foundation for a new subfield of classical thermodynamics, also called as geometrical thermodynamics.
The example of first law of thermodynamics for industrial application is steam engine power generator. But how first law of thermodynamics is applied? The heat energy will convert to mechanical energy. After that, the mechanical energy will convert to electrical energy to generate the steam engine power generator. The example of first law of thermodynamics for commercial application is air conditioner. Do you know how the air conditioner can make us feel cool? When a system undergoes a thermodynamic cycle, the net heat supplied to the system are from the surrounding. The absorption of the heat by the refrigerant in the air conditioning system is equal to the net work done by air conditioning system on its surrounding. According to the first law of thermodynamics, all energy must be conserved. Energy is conserved in the refrigeration by having both an evaporator and a condenser.
This is a Brayton cycle. A Brayton cycle is a fundamental part in building jet engines. Firstly, the ambient air is drawn into the compressor. Secondly, the compressed air runs through a combustion chamber. Thirdly, the pressurized air then gives its energy expanding through a turbine. Finally, the heat is rejected. The jet engine runs based on a Brayton cycle. Firstly, in the diffuser, air increases its pressure slightly. Air is compressed to a higher pressure in the compressor. Air mixed with the fuel in the combustion chamber, and the mixture is burnt at constant pressure. The high pressure and temperature gases exit the turbine to generate enough power to drive the compressor and the auxiliary equipment. The gases expand in a nozzle to the ambient pressure and leave the engine at high velocity. This is an Otto cycle. Number 1, the pressure is near atmospheric pressure and the gas volume is at a minimum. Number 1 to 2, the piston is pulled out of the cylinder and the intake valve is open. leaving pressure is constant and the volume is increased. Number 2, the closing of the intake valve happens here. Number 3, the heat is released and the temperature increases, so does the pressure. Number 4, the piston is driven to the crankshaft. Number 5, the exhaust valve is opened and residual heat is let out. Number 6, the piston moves back to the cylinder. This is an example of an industrial appliance, which is a 4-stroke engine that uses the Otto cycle principle. Starting from the intake stroke, air-fuel mixture is introduced to fill the combustion chamber. The valve closes when air-fuel mixture is sealed in the cylinder. From the compression stroke, trapped air-fuel mixture is compressed inside the cylinder. It reduces the charge from a large volume to a smaller volume in the combustion chamber. The ignition event, charge is ignited and rapidly oxidized through a chemical reaction. And then at the power stroke, hot expanding gases force the piston head away from the cylinder head. Finally, at the exhaust stroke, gases are expelled from the combustion chamber and released to the atmosphere.